everybody. Nothing really? Nothing from my own students, all right. That's great. So, I guess mine is a little less career-oriented in general, and mine's a little bit more focused on data analytics. So those of you who know me know that I love data analytics. All right, I know my shirt says I only like it. I work for a couple of different companies, but they're all government contractors, and as Jake stated, I do a lot with Cyber Command, the Air Force, and Air Force Cyber, and places like that. So there are a lot of positions open right now, and they are looking for people with varying skill sets. But remember that data analytics is one of those skill sets that still relates very highly to cyber. So I'm going to show you one of the cool things that we did with it, and hopefully I know how to use this controller. There we go. All right. So a few years ago, we actually did a study with Twitter, with their actual help, to try to figure out where a lot of this automated and bot-related traffic was. So we originally set out with this cool go of finding essentially any indicators that related to bot traffic and doing this really mathematical and scientific approach of analyzing everything. It's really boring, all right? This was PhD-related work, and it wasn't a whole lot of fun. What was fun was actually visualizing a lot of this and seeing what you could get out of it and playing with really high-performance computers and clusters and all sorts of cool stuff. So we did some cool stuff with it, and when we were done, we actually came up with what we called a classification for human bot or cyborg. So actually telling what traffic exists on these networks that's fully automated, partially automated, or not automated at all. And we've carried this work with a number of other researchers over the years into creating a system that's able to classify this across all social networks combined. So we currently do this over 100 different social networks and try to find all that automated traffic. To put this into perspective, the current political campaigns that are happening right now with Trump and Hillary and everybody, we're seeing 72% of all traffic being bot-related. So this is a huge volume of traffic. We're talking hundreds of thousands of posts a minute for bots. So essentially, we looked at the Blackhole Exploit Toolkit to begin with. Is anybody familiar with this at all? So the Blackhole Exploit Kit was a Russian-created hacking toolkit, and it created a series of vulnerabilities, and it would package them all up into what we call a polymorphic piece of malware, or an ever-changing piece of malware. And it had thousands of potential possible combinations for that malware. So we wanted to detect this because we saw it slowly gaining a lot of interest. And on a lot of the darknet forums, people were paying more and more money for this. So think of it like a commodity that's being traded. The cost of it goes up because more people want to buy it. So you guys today can go out and buy this if you want. All right? There are websites you can go to, and for about $3 grand a copy, you can download this and infect your own systems and remotely control as many computers as you want. Right? Now, you will need to use something like Google Translate because it is all in Russian. But one of its telltale signs is that to infect things or make them part of the botnet, it actually creates very unique sets of links using an artificial intelligence to actually try to manipulate the text in a way that's normalized. So it's trying to talk to you, essentially. It tries to post something directly to you and get you to click on it or respond to it. So kind of like targeted phishing. So in 2012, about 27% of all the malicious infections that happened anywhere on the internet came from BEK. So this is your everyday, script kiddie downloading the program and infecting thousands and thousands of computers. It was so bad that at one point, Google Safe Browsing actually had 29% of all the malicious URLs that it detected in one day being caused by BEK. Okay, so this was a really big deal at the time. In 2012, the end of 2012, they released the version 2 of it, and the creator actually made a small mistake, and it gave away his identity. So they were able to raid his house in late 2012 and actually shut him down and shut the whole project down. Now, since then, lots of copycats have sprung up. So One of the things that it did, like I said, was use an AI to create these messages that would be semi-targeted. The most well-known that the news picked up on was this one up at the top here. It's you on photo, and then a link of you with your username .jpeg or .png. Right? So think of this like with a Russian accent. It's you on photo. What it turned out was if you wrote a regular expression, you could actually detect other variants of this that existed. And there were thousands of them. So we had things like, you were nude at party, cool photo, and then the photo after it. Right? Believe it or not, people clicked on these. Right? You get a message at your username on Twitter, it's you nude at a party, and you're thinking to yourself, I was never nude at a party, but you still click on it? It seems a little concerning to me. But everything related to photos because it was a malicious JPEG that it actually attached to it. When a system, when you clicked on it, your system became infected, and it became part of the botnet, and it actually used your Twitter ID and your Twitter account to infect other accounts and to remotely control the entire botnet. So if a command was issued like, say hi to Google, what that really meant was everything in the botnet would ping flood Google. Right, so this was natural language command and control systems. Right, so it's very hard to detect this sort of traffic. But we looked at a lot of different ways of doing this, and in the end, we came up with 3 really unique features. This, by the way, is an example of the control panel. This is such a well-written piece of malware that it actually comes with its own web GUI for managing your millions of infected bots. It has a D3 visualization of the bot network for you, and you can click on different segments of it. It's pretty cool. Yes, I did get a copy of this and play with it, just because I'm sorry. Okay. And it has some cool stuff like it uses packing technology with binary obfuscation and antivirus avoidance, so it's a very hard thing to detect. So what we did initially when we were playing with this, we were kind of going at this approach blind. We had no idea what to look for, and we didn't want to actually decompile binaries and do all that sort of stuff. We wanted to look at just the data we could get publicly. So we took about 175 days of Twitter data, 50 to 80% of Twitter at the time. Now, you guys probably know that Twitter is the most talked on social network that exists today. So we're talking 8,000 messages per second on a daily basis. Back then, it was about 175 million a day, so it was much less. Right? And put that into perspective, that's about 65 billion posts per year. So we were just looking at a small time frame within that. We collected it all, and we ended up with this gigantic data set of 165 terabytes, which back in 2012, when your largest hard drives coming out were just 2 terabytes, this was actually hard to maintain and deal with. Not so much nowadays. It's actually really easy. So we looked at all of this information, and we decided, all right, let's just take the real simple approach. Let's just write a regular expression and actually process through all of this data and see if we can find any matches. And sure enough, we found many matches, close to 1 million matches in all of the data. But it took a long time. Now, to put this into perspective, those of you who know me know that I have a lot of computing resources at my disposal. I had 149 8-core physical servers, okay? And this took 14 days for the regular expression to run across all the data using those, maxing out all of the CPUs constantly. Okay? So probably not the most efficient way of doing this. And just to add to it, yeah, I did it in Python, which is really not the most efficient way to do this. So the next thing we tried was, well, that's cool. If a regular expression shows it and we have all these keywords, let's do some Google hacking and see if there's more than what we're detecting out there. So just something as simple as site, twitter.com, it's you on photo, or any of the other words or phrases that we came up with. And we found, wow, you know, there's a little more than twice what we're detecting out there. So maybe this approach is not the best approach. And more importantly, nobody wants to wait 14 days after hitting enter for there to be a result on the screen. And you know, that result was just a counter that said there were this many infected accounts found. Right? So probably not the best way of doing it. So the next thing we decided was maybe we could look at this mathematically. This is really boring. All right? Everybody Anybody who's ever seen an entropy-based equation knows that this stuff is just boring statistics. But what came out of this was this cool separation of things. And what we found was all of those dots at the top of the graph were human beings talking. And all those dots clustered in the middle there were bots talking. And we realized that there was actually some cutoffs that we could find, and we could do some clustering and say that anything above this is a bot, and anything below this, I'm sorry, the other way around, anything above this is a human, and anything below is a bot. The problem was, we kept finding these weird outliers at the end, and we didn't know what to do with those. They didn't make any sense to us. It was like they were a bot and they were a human being. And that's kind of weird. Until you start delving into the data and you realize it's like Katy Perry talking or something, right? This is people who pay for automated services to act like they're actually posting at regular intervals. So, this was interesting, but it was still kind of boring. Slightly more interesting was looking at the API calls that these things were making and what devices were actually making the calls. And we realized that, I know you probably can't tell from the graph here, but essentially we had web, like people using their web browser to access Twitter, iPhones, and other. And other was things like Symbian OS or Android OS or things like that. And what we found was most of the malware that exists on social networks is using some sort of a mobile API. And that got us really thinking, wow, so it's maybe not actually the computers that are infected, it's the phones and the portable devices that are being infected. Right? And they're the ones accessing and making all the requests and calls. So this meant something a little more to me personally, because I'm really interested in all that, portable device exploitation and what you can do to drain people's batteries and all that sort of stuff. So, slightly more interesting, we took this and we ran it through again using just the entropy and just the mobile device types and did a search on the data. We found that this was way easier to compute than a regular expression. It was something that we could compute very fast. That same set of data that we processed before only took us about a day to run this time. So we had, from 14 days down to a single day to pass through it. That's looking at 6 billion posts. So essentially like 1/10 of everything that happened in 1 year of Twitter. Okay? And we were able to find a lot, 729,000 infected accounts. These are actual accounts that have been taken over and devices associated with those accounts that have been taken over. And moreover, we were able to find things like mobile phone numbers. So we could actually say that this account associated with this mobile phone is infected. So if you wanted to, you could call that person up and say, hey, by the way, your phone is infected. And we did that a few times just for fun. Most people hung up on us, but I did get one guy to talk to me. So we took this research and we carried it for years, and we've got a lot of people who worked on this, kind of fine-tuning it and making it faster. Earlier this year, we managed to borrow some equipment from Oracle. They have a new system called T7, and it uses this really awesome processor that they've created. And to give you an idea, this is 16 threads per core with 8 cores per CPU and 16 CPUs, all in a 1U box. Okay, so 2,048 physical threads running Java on top of that, so you get about 4,000 threads per process on top. So massive numbers. We had a 500 terabyte iSCSI SAN attached to this thing. And we were able to, after 14 hours of loading the data into RAM, yes, it takes 14 hours to copy all this data from disk, we were able to process in less than 5 minutes all of Twitter for 2012. 100% of all of the data given to us by them. And with that, we were able to find 1.8 million infected accounts. You may be thinking, well, that's great. 1.8 million infected accounts from 2012. It's 2016. Josh, who the hell cares? Right? The fact was, we were proving a concept. We took this and tweaked it ever so slightly, and we were able to use this to identify in current terms, in real time, any bots, cyborgs, or humans that are posting by the second on all of the data on Twitter. And we were able to do this on just a little 1U box. So essentially inline filtering Twitter. And what we ended up with was this giant dense area here, which is all bot traffic. This area here, which is all automated traffic, all your singers and pop stars and everything, all with their posting services. And then everything above that is human beings talking. And you may be thinking, why are some of these people way, way up at the top? Entropy is one of these things that measures the density of speech. So people who use really complex words, or more educated essentially, will have higher scores. So this was great. It came up with a really simplistic way of doing this without using any machine learning or artificial intelligence. And we've gone one step further recently, where we've gotten this thing down to essentially just commodity hardware. So we can run this on a laptop, and we can monitor real-time everything that pumps into Twitter at any given time on just your standard run-of-the-mill laptop. So what does that mean for us? It means we can create things like automated spam detectors for your web browser that look at the actual posting content and determine whether or not it's spam or bot-related, if it's malicious, if it's not. We've done a lot of cool stuff with this. And like I said, the political campaigns have actually approached us and have been talking to us about how they can essentially bypass this. Right? They don't want to be detected by this with their 72% automated traffic. So obviously we don't want them to do that. We want them to be detected and filtered out. One of the significant things that we found within this was that there are cyclical patterns to these social networks, and there are times of the day that people post and don't post. And we found that when there are major events like the Paris attacks last year, there are significant upticks on here before the event. So you guys have watched all the spy movies and shows, and they say, there's an uptick in the chatter, right? And it doesn't actually mean anything in real life. Well, we actually found upticks in the chatter on social networks before major events. Now, we're working right now on tying those to the major events. But still, there was some cool stuff on there. Any questions? Mine's not as fun and interesting. I don't have a wig. I do need a wig. I'm losing everything on top here. So. Yes?
If you can hear me.
Yep.
A quick question for you. How many, are you not getting commercial carriers like an AT&T or T-Mobile by any interest in finding infected people on their network for this research?
Yes and no. Yes, a couple of the larger carriers we've talked to, they're more the internet service providers, less of the mobile carriers that are interested. And the larger carriers like L3, Global Crossing, things like that, are interested because they see the amount of bandwidth they're wasting to things like this. Haven't really talked to the mobile carriers about it. We've gone right to the social media providers and said, wow, if we're having a hard time storing all this data to analyze, you must be having a heck of a time storing all this data just to make it available to people. If we can eliminate a huge percentage of your traffic and call it bot traffic, you can dump it and not store it. Unfortunately, we run into the opposite effect that we expect to get out of this. The social network providers want to report to you all the time that more and more people are using their networks. You should invest in them because they've got an uptick of 50% new users and things like that. They want the bot traffic because the bot traffic looks like new uses, and then people want to invest more in their companies. So a lot of the social network providers have been very closed-doored about this.
Can you say anybody get the data?
Yes, absolutely. We have GitHub repositories posted with sharing agreements and lists of all the data sets and all that sort of stuff. Unfortunately, we don't just post 165 terabytes on GitHub. I don't think they would appreciate that. But we can set you up with links and things to download it. They have weird restrictions about sharing a lot of these data sets. Like you have to have a signed agreement in place and you have to know who the person is you're sharing it with and stuff like that. I would love to just set up an anonymous FTP and let everybody go for it, but well. Oh. Okay. Was I too early? I finished early.
Thank you very much.